Okay, now the game's going to change a little bit on this one. A bank account contains $5,000 and earns 3% interest each year. How many years will it take the account to reach $6,000? This time we're finding the number of years it takes. So we have money, years, nothing new so far, X and Y. Things aren't going to change till you get down here. And the dollars per year, again, it's a percentage per year, so there is no steady dollar amount per year. It's just a 3% interest, so that'd be going up. Remember, it's times, not mx anymore, g to the x power and y. So we know we have $5,000 at the beginning here. And we know that our g here is our growth factor. So I take 100% plus 3%. And that's 103%, which of course is 1.03 when you write it here. So I have $5,000 times 1.03 to the x power equals y. Now, use that. I'm done with that. $6,000 would not go in for x. That would go in for y here. Okay, so we're going to put it in for y. Well, that changes the game because now I'm solving for x. X is a power. Here's what you need to do at the beginning. You need to circle the base in the exponent. X is the power. Its base is just 1.03, so just circle that. And before I worry about this, that 5,000's got to go. Now, 5,000 is a multiplier. So you divide both sides by 5,000. Underline those. So 5,000. Okay, so 1.03 to the x power. Keep that circled. Okay, and split it then. So 6,000 divided by 5,000 is 1.2. Sorry, I should have done the split right there. Now, how do you find exponent? Well, I have no idea how many 1.03s it takes to multiply to 1.2. So I need to use my log over log formula. So my power of x is equal to my log divided by my log. The base has to go on bottom, so 1.03. You can't flip them around, okay? You have to put the correct one on bottom and then the other one on top. Okay, so then I go into my calculator, I go log 1.2, close it, divided by log 1.03, close it. And that gives me about 6.16 years, so I'm going to put between 6 and 7 years. So 6 and 7. All right, next one. In the year 2000, the average price of a football ticket is $50,000. Tickets are increasing by an average of 6% per year. How many years does it take the price of a ticket to reach $75? So I've got money and years. If you go into a business field, you're using this stuff all the time. X is years, Y is money. Dollars per year is unknown. There's no steady dollar amount. It's a percent, 6%. That's increase. So it's not a steady increase, just an increase. So XY times g to the x power, and then y right there. Okay, so my y is money. So I know the money started at $50. Okay, then my G is my growth factor. We always take our 100% and then adjust accordingly. We add 6% on that. Okay, so my growth factor is 1.06. Okay, now we can write our equation. So I've got 50 times 1.06 to the x power equals y. Okay. Now again, $75, okay? That's what they're asking me about. That has to go in for y, so 75. Okay, you circle your base and exponent and split it. Now before you worry about that, you need to divide by your 50. The 50 can't be there. You need to divide by your multiplier of 50. Okay, that's going to be 1.5, and then we got 1.0. So a lot of people subtract that number, and it's wrong. I mean, that's an automatic not passing the standard if you do that. Okay, now I'm good to go. I can take my power of x and set it equal to the log divided by log. I know that my base is 1.06, and to find out how many 1.06s it would take to multiply to 1.5, we can use our log over log. So log 1.5 divided by log 1.06, okay? And that's 6.95. So it's going to be between 6 and 7 years again, okay? All right, last example, I'm going to go here. And you have two of them to do. A new car is purchased for $16,000. The car declines in value by 10% each year. Find how many years it takes a car to get down to a value of $5,000, because that's when I want to sell it so I can get some value back for it. So I've got money and years. So it's X and that's Y. Dollars per year. I don't know that. Okay. It's a 10% decline. There's no steady dollar amount, which is a decline. Whoops. So X comma Y times G to the X power, and then Y. Okay, so our beginning amount is 16,000. Now I got to get a growth factor, so I take 100% and minus 10%. That's 90%. Okay, so 90% is less than 100, so now it's 0 point and then 90. Okay, so I've got 16,000 times 0.90 to the x power and then y. Okay, now $5,000 obviously again is a y value, because the years are what I'm solving for. I'm solving for the years, so I put 5,000. Now again, you see that x is a power, so you circle the power in its base and split it. But before I use log over log, I need to divide by 16,000. Okay, and then whenever I do that, first I divide by that. So 0.90 to the power of x equals 0.3125. That's short enough, you can just write it out. Okay, now that there's nothing out the circle, I can take my x variable and set it equal to the log over log. So I know my base is 0.90 and then 0.3125, and we'll see what we come up with. So log 0.3125 divided by log 0.90. I come up with 11.03. Okay, it's really close to 11, so it'd be like sometime immediately after 11 years passed. Okay, that's really all I was saying on that today. I hope it's been informative. Remember, when you're solving for the x is a power. You're going to have to use the x equals log over log, but first you have to divide by your multiplier.